Okay, mathmates, it's time to review what we learned in this playlist. Real numbers, integer, whole numbers, natural numbers, rational numbers, irrational numbers. We're going to put it all together and see what we learned. What is Emoji Betsy up to now? This is my we can do this attire, mathmates. Let's ace this review. Got a bandana on and all ready to go. Okay, so if you want, and it's helpful, pause the video as we do these and do them for yourself first, and then check the answers. Let's take a look at the first one. We need to determine what sets 22 fall in. Do we remember our integers and whole numbers and everything? Well, first of all, we talked about real numbers. Real numbers is any number you can put on the number line. So 22 can be put on the number line, so it's real. Integers. Integers are your positive, negative numbers and zero, no decimals. Does that have a decimal? Nope, so it's an integer. And our letter for integers is Z, our symbol. Whole numbers start with zero and go up, no decimals. So 22 is a whole number, it's positive. Natural numbers are our counting numbers. Can we count to 22? Yes, so it's a natural numbers. And if it is an integer and a whole number and a natural number, it's definitely a rational number. Remember, irrational numbers have a decimal that goes on forever. All right, let's take a look at the next one. Negative 1.5. Well, I can put that on a number line, so it's real. It has a decimal. Because it has a decimal, it can't be an integer, it can't be a whole number, it can't be a natural number. But that decimal ends. Because the decimal ends, it's a rational number. There we go. How we doing, mathmates? All right, let's take a look at the next one. Remember to simplify before you determine whether or not it belongs in each set. The square root of 16 is 4. 4 times 4 is 16. So let's simplify that. That's 4. The square root of 25 is 5. 5 times 5 is 25. So we've got a fraction. Can I put a fraction on a number line? I sure can, so it's real. 4/5 is 4 divided by 5, which is 0.8. That's a decimal. Since it's a decimal, it can't be a whole number, it can't be an integer, and it can't be a natural number. Now, 4 is an integer and 5 is an integer. You have an integer divided by an integer, which makes it rational. Or you can just look at the 0.8. 0.8 ends, so it's rational. Negative 232. Yep, we can put that on a number line. It's an integer because it doesn't have a decimal, so it's an integer. It is not a whole number because it's negative. It's not a natural number because it's negative. But it definitely is a rational number. If it's an integer, it's a rational number. There you go. Look at the next one. Yep, it's a decimal. We can put it on the number line, so it's real. It has a decimal, so it's not an integer. It's not a whole number. It's not a natural number. It repeats. The 5 repeats. If it's repeating, it is rational. And let's look at the last one. 0 divided by 24 is 0. Well, I can put 0 on the number line. Integers include 0. Whole numbers include 0. Natural numbers start with 1, so it doesn't include 0. And since it's an integer, it's definitely rational. I didn't put any irrational on here, but let me just put an example. So 3.692448 ... It keeps going on, it's irrational. If it's the square root of any odd or any prime number, the square root of 19, 19 is prime because only 1 times 19 is 19. That will be irrational. So just a few examples there. All right. How are we doing? Maybe you want to clear this off and try it again for yourself. Let's take a look at the last page here. Oops. One more page of review. All right. Well, math mates, are we ready to move on? We have many more concepts to learn. AI isn't doing that great of a job with generating my photos, is it? But this one's better than the last one, so I shouldn't complain. All right, let's take a look here. So we are going to first decide by reading the problem what operation we're using. So number one says -2 minus 7. So what am I going to do? I'm going to circle the number with the sign in front of it. Remember, a minus and a negative are the same thing. Now, they're both negative. If they're both negative, our answer is negative. And since the signs are the same, you add the numbers. 7 plus 2, 9. How do we do, math mates? All right, let's take a look at the next one. We're doing multiplying and dividing here. 6 times 5 divided by -2. When I look here, there's only one negative. If there's an odd number of negatives when you're multiplying and dividing, the answer is going to be negative. But let's go through this. So I got a +6 times a +5. If there's no sign, it's positive. 6 times 5 is 30. Then I got to divide that by -2. So when I look at this, I've got a +30 and a -2. The signs are different, so it's negative. 30 divided by 2, 15. Just like we said, there was one negative in the problem, one is odd, so the answer is negative. How are we doing, math mates? Let's take a look at the next one. 8 minus -1 plus 5. We've got a double negative, so what do? Make that a positive. You guys remember that? Then left to right, a +8 and a +1 makes +9. And then 9 plus 5 is 14. Always start from the left and move to the right. Let's take a look at the next one. What's going on there? I got 0, which isn't positive or negative, and -7. So 0 does nothing. So our answer is just that -7. We doing okay? Number 5, it's either dividing or multiplying. 22 divided by -11 times -1. Since it's all division and multiplication, count your negatives. I've got 1, 2. 2 is even, so our answer should end up being positive. Here we go. You ready, math mates? I got a +22 and I got a -11. The signs are different, so it's going to be negative. 22 divided by 11 is 2 times -1. Now, let's circle them. I got a -2 times a -1. The signs are the same, so it's positive. A negative times a negative is a positive. I'm done with the signs, then just multiply the numbers. 2 times 1, 2. And that's what we said. There were 2 negatives. 2 is even, so your answer is positive. How we doing, math mates? Let's take a look at the last one. -1 minus a -5. Right away, I'm going to change that to a plus. -7 minus 2 plus -2 plus 9. All right, here we go. So I've got a -1 and a +5. The signs are different, so subtract the numbers. 5 take away 1 is 4. The 5 is bigger and is positive, so it's positive. I'm just going to write the rest of this out. Let's move on. Always left to right, so always start and move this way. So now I got a +4 and a -7. The signs are different. So subtract the numbers. 7 take away 4 is 3. The 7 is bigger and it's negative, so it's -3. I just wrote the rest of the problem down. I'm just going to do one step at a time. Everybody doing okay? Left to right again. -3 and -2. The signs are the same, so add the two numbers. 3 plus 2 is 5. Take the sign down. Then I got plus -2 plus 9. How are we doing? This one's a little different. I did this on purpose. I want you to see it doesn't matter. So I got a -5. Take the sign in front of the 2, which is a -2. The signs are the same, so add the numbers and take the sign. You see what I did? It didn't matter that it was plus a -2. I just took the sign that's right in front of the 2. And then lastly, I've got a -7 and a +9. The signs are different, so subtract. 9 take away 7 is 2. 9's bigger, it's positive, so our answer is positive. How do we do, math mates? Maybe you can go through and do these again just to make sure you got it. If you got any questions, leave them for me. And again, don't use a calculator. I'm telling you, this will make your life so much easier if you can learn this. You'll start to love math more when you understand the more basic skills. If this helped, I would appreciate if you subscribe and share. Thank you.